Let us now discuss the topic of momentum equation. मोमेंटम इक्वेशन का जो टॉपिक है काफ़ी ज़्यादा सिंपल एंड छोटा है और आपके सिलेबस के हिसाब से इम्पॉर्टेंट भी है, क्योंकि पिछले 2-3 सालों से आपके पेपर्स में मोमेंटम इक्वेशन की एप्लीकेशन के रिलेटेड सवाल पूछे गए हैं। मोमेंटम इक्वेशन आपकी एक सिंपल इक्वेशन है जो बेस्ड है आपकी कंजर्वेशन ऑफ मोमेंटम की थ्योरी पे। We know what momentum is. Momentum is simply defined as the product of mass of the system with the velocity of system. That is, mv of the system gives us the momentum of the system. Let us now derive the momentum equation. We know, as per Newton's law of force, or I will say the Newton's law of net force, हमारे पास जो सिस्टम में नेट फोर्स होता है that is equal to the mass of the system multiplied by the acceleration of the system, that is F is equal to ma, जहाँ पे हमारा F जो होता है वो रिजल्टेंट फोर्स होता है। अगर आप नेट फोर्स किसी पर्टिकुलर डायरेक्शन में लेकर चलेंगे, से इफ यू आर considering the net force along x direction, then the acceleration has to be in that particular direction only. That is, अगर आप x direction की बात करेंगे, then fx has to be equal to m multiplied by ax, where ax is the acceleration of system in x direction. Fine. So we know that f is equal to ma, and where a is equal to the derivative of velocity, that is time rate of change of velocity. So we can write force as mass multiplied by time rate of change of velocity. We know that this mass is a constant thing and can be taken into this derivative. So I have written here that F is equal to change of mv with respect to time. This mv is nothing but our momentum. So we can say that force is equal to time rate of change of momentum, or we can say rate of change of momentum is equal to the net force acting on the system. इस इक्वेशन को हम ऐसे भी लिख सकते हैं that F dt is equal to dmv, that is impulse of the force. आपने सेकेंड सेम में आपके इंजीनियरिंग मैकेनिक्स में इम्पल्स का टॉपिक काफ़ी ज़्यादा अच्छे से पढ़ा हुआ होगा, एंड यू माइट बी नोइंग दैट व्हाट इम्पल्स इज। इम्पल्स हमारा एक शॉर्ट टाइम पीरियड में लगने वाले फोर्स को कहा जाता है विद द इम्पैक्ट। सो मैथमेटिकली बात करें तो इम्पल्स इज नथिंग बट force multiplied by that small duration of time. So here we can see that impulse is equal to change of momentum. This equation, that is impulse is equal to change in momentum, is termed as momentum theorem or momentum equation or impulse momentum equation. That is, as per our momentum equation, इम्पल्स जो आपके सिस्टम पे लगने वाला है दैट विल बी इक्वल टू चेंज इन मोमेंटम। जो मोमेंटम इक्वेशन हम अप्लाई करेंगे इन फ्लूइड्स, आप ख्याल रखिएगा दैट दिस इज एप्लीकेबल टू ओनली न्यूटोनियन फ्लूइड्स। नॉन न्यूटोनियन या कोई और किस्म के फ्लूइड्स के लिए ये एप्लीकेबल नहीं है। दिस इज एप्लीकेबल ओनली एंड ओनली फॉर न्यूटोनियन फ्लूइड्स। Now let us check the application of momentum equation. Momentum equation का यूज़ हर उस कॉन्सेप्ट में लगता है जहाँ पे हमारा इम्पल्स का क्राइटेरिया आता है। दैट इज़ जहाँ पे भी आपको इम्पैक्ट कैलकुलेट करना होगा, we do utilize momentum equation. Now, as per your syllabus, you have to check out the application of momentum equation to pipe bends. Now what happen in pipe bends? जब आपकी किसी भी पाइप में फ्लो हो रहा होता है, if there is change in velocity, कहीं पे भी आपकी पाइप में वेलोसिटी चेंज हो रही है, because of change in velocity there will be obviously the change in momentum, एंड दैट चेंज इन मोमेंटम की वजह से हमारा जो पाइप पे फोर्स लगने वाला है दैट विल चेंज, एंड आपके पाइप पे फोर्सेस एक्सर्ट होने वाले हैं। आपने देखा होगा आप किसी भी पाइप में जब अचानक से टैप ओपन कर देते हैं आपके पाइप में कर्वी मोमेंट आता है, दैट्स बिकॉज ऑफ दिस थिंग ओनली, क्योंकि आपका वेलोसिटी सडनली इंक्रीज होने पे आपका जो फोर्स है पाइप में वो चेंज होता है, एंड जिस डायरेक्शन में आपका फोर्स एक्सर्ट होगा उसी डायरेक्शन में आपका पाइप जो है वो मूव करने लगता है। दैट इज देयर इज सडन चेंज इन द फोर्स विच इज एक्टिंग ऑन द पाइप्स। नाउ जब हमारे पास मशीन पार्ट्स डिज़ाइन करने होते हैं दिस थिंग हैज़ टू बी कंसिडर्ड वेरी वेल, बिकॉज इन योर मशीन्स पाइप्स में फ्लो कैन बी ऑफ वेरी हाई रेट, एंड जब उस हाई रेट ऑफ फ्लो की वजह से आपके पाइप बेंड्स पे प्रेशर एक्सर्ट होगा दैट कैन कॉज द आउटरेज। दैट्स वाई दिस थिंग इज इम्पॉर्टेंट। आपका जो भी चेंज इन फोर्सेस लगता है दैट हैज़ एडवर्स इफेक्ट इन केस ऑफ पाइप बेंड्स, जहाँ पे आपकी पाइप में बेंड्स आते हैं या अगर आपका जॉइंट्स आते हैं आपके पाइप्स में, बिकॉज यूजुअली जॉइंट्स आर यूज टू कनेक्ट द पाइप्स ऑफ टू डिफरेंट क्रॉस सेक्शंस, एंड जब आपका क्रॉस सेक्शन चेंज होगा आपकी वेलोसिटी चेंज होगी, एंड वेलोसिटी चेंज होने पे आपका फोर्स change hoga, and that force change can be adverse to that pipe system. Now let us see the momentum equation for that pipe bend. Using this momentum equation we do find out the forces that are going to act on the pipe bend, and then we can design the bends accordingly. But do remember one thing, that we know that momentum is equal to mass into velocity. But when our flow is going on, that is our fluid is moving on with a high velocity, we cannot just consider the mass of the fluid system. Thus for a flowing fluid, we do consider mass flow rates. What is mass flow rate? Mass flow rate is nothing but mass flowing per unit time, and I have here represent it as m star. It will be having units of kg per second because it is mass per unit time. Now we know that momentum is equal to mass into velocity, and that is going to have units of kg meter per second, kg of mass and meter per second for velocity. The time rate of change of momentum will be equal to mass into velocity per unit time and will be having units of kg meter per second square. Now if we do consider the mass flow rate for momentum, that is mass flow rate multiplied by velocity, that will give us the units same as that of the time rate of change of momentum, that is kg meter per second square. Thus, mass flow rate multiplied by velocity will directly give us the time rate of change of momentum, and we do not have to equate the time rate of change of momentum to the force, but we can just simply equate the momentum obtained by multiplying the mass flow rate with velocity to the force, that is the net force. So let us now analyze the pipe bend actually, which is concerned with your syllabus. And for the derivation of the force acting on the pipe bend, let us consider that the fluid flowing in the pipe is ideal. So here we have considered a pipe a pipe having a bend at a theta degree with horizontal. For analysis, we do consider two control sections, that is here this section and this section. For this section, the pressure force will be in this direction, that is perpendicular to this section, and at this section let us assume the area is A1 and let us assume the velocity is V1. Now for this section, let the pressure be P2 and area of cross section A2 and velocity V2. Why do have I considered two different parameters for the pressure, area and velocity? Do remember one thing, अगर आपके पास पाइप है जिसका क्रॉस सेक्शनल एरिया थ्रू आउट चेंज नहीं हो रहा है बेंड के पहले और बेंड के बाद, then the pressure and the velocity will remain constant because your velocity is dependent on your area and your pressure is dependent on your velocity. अगर आपके पास एरिया ऑफ क्रॉस सेक्शन इन दो पर्टिकुलर क्रॉस सेक्शंस पे सेम है, देन प्रेशर एंड वेलोसिटी भी सेम रहेगा. हाउएवर अगर यहाँ पे और यहाँ पे आपका क्रॉस सेक्शनल एरिया चेंज हो रहा है, then you have to calculate velocity and pressure accordingly. Now let us consider that rho is the density of fluid flowing in this pipe, and obviously this direction is your x direction and upward direction is considered as positive y direction. Now let the force acting in the net force acting in this x direction be Fx, but Fx will be the force exerted by fluid on the pipe, and let the force in y direction be Fy, because here in this for this cross section you will be having force only in x direction, but when you will cross this bend, the flow is going at an inclination of theta degree and you will be having both the x component and y component. So for a whole of this bend we will be having a resultant force that will be combination of x and y components. So let Fx be the x component and Fy be the y component of force exerted by fluid on the bend, and bend will exert the equal and opposite force onto the fluid system. So if we calculate the forces that fluid is going to exert on the pipe bend, on reversing the direction we can check out the what force pipe bend is going to exert on the fluid. You will get to know this thing in derivation, what I was actually saying. So we have considered that Fx is the force exerted by fluid onto the bend in x direction, and Fy is the force exerted by fluid in y direction. Now let us apply momentum equation. For x direction, we will be having pressure force because of this pressure P1, and that will be equal to P1 multiplied by A1. That is pressure force is equal to pressure multiplied by area. So I have written P1 A1. Now here pressure P2 will be at an inclination and will be in this direction, and will be in this direction. Perpendicular this plane, perpendicular to this cross-sectional plane, and we do have to resolve that pressure into components of x and y. Here pressure is in this direction, so component of force in x direction will be opposite to this pressure force, that is P1 A1. So that's why I have written pressure force because of P2 as negative P2 A2 and cos theta. Theta is the angle at which the pipe bend is. So then we have force acting on the fluid by pipe bend. As we have assumed the force that is acting on the bend because of fluid in x direction as Fx, so bend will exert the same force but in opposite direction. That is why we have written here as minus Fx. That is the force that will be exerted by pipe bend onto the fluid, because here we are considering the forces acting on the fluid system. Now all these forces, that is the net force, will be equal to mass per second multiplied by change in velocity, that is mass flow rate multiplied by change in velocity, that will give us the change in momentum. So on simplifying, we have written mass per second as m by t, and change in velocity in x direction will be, initially the velocity at this section was v1, and here at this section the velocity is v2, but this velocity will be resolved into components along x direction and y direction. Velocity is in this direction, and the component of velocity along x direction will be along the positive x direction. That's why we have written here as positive v2 cos theta multiplied by v1. That will give you the change in velocity, and that we have multiplied by mass per second. We know that mass of the fluid system is given by density of the fluid system multiplied by volume of that system. So we can write m as rho v divided by t. Now this volume per unit time is nothing but discharge. So we can write mass per second as density of fluid multiplied by discharge. And on solving the equation, we can find out that Fx will be equal to rho q multiplied by v1 minus v2 cos theta plus p1a1 minus p2a2 cos theta. This will give you the force acting in x direction onto the onto the bend, because here it is Fx, and the negative of this pressure will be acting on the fluid system because of the bend. Now in y direction, we will be having pressures like, for this section 1, we won't be having any pressure in y direction because here we do have flow in x direction only. So pressure in y direction will be equal to 0. That's why we have written 0 over here. And in y direction we will be having component of pressure P2 because of pressure P2, and that will be strictly acting downwards. So that's why we have written minus P2A2 sine theta, and the pressure exerted by pipe bend onto the fluid, that will be equal to Fy, and that we can equate to same mass per second multiplied with change in velocity, and that mass per second is nothing but density of fluid multiplied with discharge, and velocity at section 2 will be now equal to v2 sine theta, that is the component of velocity in y direction, and initially in y direction we were having 0 velocity. So on simplifying, we can find out the value for Fy. Now the resultant force that will be acting on the pipe bend because of the fluid system will be given by this equation, that is resultant force is equal to Fx root of Fx square plus Fy square, and that will be acting on the inclination that will be given by the tan theta. We know these terms long back, that is tan theta is equal to Fy by Fx. So now if we will be giving any pipe system for which we will be knowing pressure, area and velocity at any particular cross section, we can simplify the things and check out the force that is acting on the pipe bend, and uh, accordingly we can design the pipe bends. Now let us check out one question based on this application. In that question we have given that discharge of water through a pipe of diameter of diameter sorry of diameter 40 centimeter is 400 liters per second, and the pipe is having bend of 135-degree with horizontal. We do have to find the magnitude and direction of the resultant force that is acting on the bend. It has been given that the pressure of the flowing water is 29.43 Newton per centimeter square. Here in this question we have been given with the diameter of pipe is 40 centimeter. That is, our pipe is having constant cross section throughout the bend. That is, the diameter of our pipe is not going to change, and if diameter of pipe is not going to change, the cross sectional area is not going to change, and if cross sectional area is not going to change, the velocity of the flow in the pipe bend has to be constant. And if velocity has to be constant, the pressure acting on the fluid will be constant. So we do have system somewhat like this. Sorry, the diagram making thing on this word is not so good. So I hope you will somehow get the wave of the pipe. Here we do have a pipe which is having a pipe bend, and the bend is at the angle of 135-degree. So let us consider the two cross sections on which we will apply the momentum equation to find out the resultant force acting on the pipe bend. So for this cross section I have put pressure, area and velocity as P1, A1 and V1, and for this system we have assumed that as P2, A2 and V2. Now pressure is 29.43 centimeter square, and that is going to be constant throughout the pipe bend because our cross-sectional area is not changing. If cross-sectional area will change, we do have to calculate the pressure P2 at the cross-section 2, and that we can calculate using Bernoulli's equation. So here we have P1 equal to P2 and that is given as 29.43 Newton per centimeter square, and we have just converted that into Newton per meter square by multiplying 10 raised to power 4. Also we have been given that discharge is equal to 400 liters per second, and we have converted that to meter per second as well. Now we do know that discharge is equal to area of cross section multiplied by velocity, and we do have calculated the value of velocity from that thing because we know the discharge, we know the area, so we can calculate the velocity, and that velocity is going to be constant throughout the two cross sections. That is, V1 is going to be equal to V2, and that thing I have calculated as 3.183 meter per second. Now we do know the terms. Let us now check out the momentum equation in x direction. We know the force Fx is equal to this thing. We know the value of density of water because it has been given that across the pipe water is flowing, so density of water has to be 1000. Discharge we have calculated as 0.40, and velocity v1 we have calculated as 3.183. Then we have minus v2 cos theta. Now why do I have written it as again minus 3.183 cos 45? See, because here the bend is at 135 degree. That is the direction of fluid flow is going across this direction. The direction of velocity will be this, and the component of velocity along x direction will be opposite to that of the direction of v1. That's why I have taken it as negative, because here geometry of pipe bend is different. That's why we have to take negative, because here it is acting along negative x direction. The and cos cos 45, because the angle then will be this angle, that is 180 minus 135, and that will be equal to 45. That's why I have written it as minus 3.183 cos 45. Then P1 we know, A1 we have calculated as pi by 4, 0.4 square. That comes out to be 0.125. Please do check the calculations, I might be wrong. Then P2 we know, A2 we know, and cos theta we know. On substituting and simplifying the things, we have find out that Fx is equal to 64973.5907 newtons. Similarly for Fy, here you must check the direction of P2 as well. Here P2, the direction of pressure is this, and the component of pressure along x direction is in same direction as that of P1. That's why I have written it as plus P2, because here negative will eliminate and it will be positive. P2 का वैल्यू मैंने यहाँ सब्सटीट्यूट करा है, and we have find out the value for resultant Fx. Similarly for Fy we won't be having any issue, because only things that will act in will be along the positive y direction, so we can just substitute the values we know and we can find out the value for Fy. And then for resultant force we know the formula, and for for direction of the force we can use tan theta is equal to Fy by Fx, and we can find out the magnitude and direction of the resultant force that is acting on this pipe bend. Please do check out this question. I have selected this question because in this question the geometry of pipe bend is somewhat different. You will be having pipe bends as explained in the derivation, and there you won't find any kind of problem. You can just simply substitute the values in the equation and find out the forces. The another type of question that is concerned with this topic is about the where you will be given two cross sections, that is cross sectional area at section 1 will be different with that of the cross section area at section 2. There you simply have to calculate the velocities either using continuity equation, and then you can check out for pressures using Bernoulli's equation. The topic is very much simple. Hope you will find it easy as well. Please check out the topic and let me know if you find any kind of difficulties in understanding the topic. Thank you.